Hi everyone, I'm Hassan Dawood. I will be presenting my foundation computing presentation. These are the contents for my presentation. There are exactly 10 topics for me to cover, so without any further delay, let's get started. First, we're going to see about the identification of internal components of CPU. The Central Processing Unit. The Central Processing Unit, CPU, is a primary component of a computer that acts as its control center. The CPU, also referred to as the central or main processor, it's a complex set of electronic circuitry that runs the machine's operating system and apps. Internal components of the CPU: arithmetic logical unit, memory registers, cache memory, memory management unit, CPU clock and control unit, and random access memory. Arithmetic logical unit. An arithmetic logical unit is a part of a central processing unit that carries out arithmetic and logic operations on the operands in computer instruction words. Let's see the functions. Basic mathematical operation. It executes arithmetic operations such as addition, subtraction, and multiplication. Second one, advanced mathematical operations. Third one, logical operations. Fourth one, bit shift operations. Fifth one, data checks through special value. Sixth one, transferring data to and from registers. Seventh one, specially programmed operations. Cache memory. Cache memory is a small sized type of volatile computer memory that provides high-speed data access to a processor and stores frequently used computer programs, applications, and data. A temporary storage of memory, cache makes data retrieving easier and more efficient. Its functions: cache memory temporarily stores information, data, and programs that are commonly used by the CPU. When data is required, the CPU will automatically turn to cache memory in search of faster data access. This is because server RAM is slower and is further away from the CPU. Random access memory. Random access memory, or RAM, is one of the most important parts of a computer. It provides high-speed, short memory for computer CPU. Its functions: RAM provides the short-term memory. The CPU needs to open files and move data around as it responds to the tasks given to it by your apps. Both RAM and CPU work synchronously and complementarily to ensure that your computer's performance fits your needs and you have a good experience when using your device. CPU clock and control unit. The control unit is a part of the computer's central processing unit, also known as CPU, which directs the operation of the processor. In computers, the clock style is the amount of time between two pulses of an oscillator. It's a single increment of the central processing unit, clock during which the smallest unit of processor activity is carried out. Memory registers. A register is a critical component of a computer memory that stores data and instructions for quick processing. It serves as an efficient temporary storage area where information can be accessed and manipulated quickly in order to carry out complex tasks. Its functions: storing the results of arithmetic and logical operations, controlling the flow of data between the CPU and main memory, keeping track of the program counter, which determines the next instructions to be executed. Moving on, we have functions of central processing units. CPUs perform logic, control, arithmetic, input and output operations specified by its programming to perform basic tasks. They are found in most electronic devices, including laptop computers, smartphones, some cameras, thermostats, and any other type of device that requires input and output program operations. Let's see the functions. Instruction execution. The CPU fetches instructions from memory, decodes them, and executes them. These instructions are the basic operations that a computer can perform, such as arithmetic operations, like addition, subtraction, and etc. And logical operations like comparisons, branching, etc. And then we got data storage and retrieval. The CPU can read data from memory, manipulate it, and write it back to memory or other storage devices like registers, cache, and RAM. Control unit. The control unit within the CPU manages the execution of instructions, ensuring they are executed in the correct sequence and that the appropriate data paths and control signals are used. Arithmetic and logical unit, also known as ALU. The CPU contains an ALU that performs mathematical and logical operations. It handles tasks like addition, subtraction, multiplication, division, and logical operations like AND, or NOT, and etc. Moving on, we got identification of different types of storage medias. Examples for storage medias. First, we got USB flash drives, and then secure digital cards, also known as SD card. Solid state drives, also known as SSDs. Cloud storage, punch cards, hard drive disks, floppy disks, tapes, compact discs, also known as CDs, and DVD and Blu-ray discs. Some examples. Moving on, computer memory. So, computer memory is basically divided into two. One is primary and secondary memory. In primary memory, we got ROM and RAM. In secondary memory, we got magnetic media, optical, and solid state media. So these are the examples. Moving on, first we got RAM. So RAM, read-only memory or ROM, is a type of computer storage containing non-volatile permanent data that normally can only be read. Moving on, we have identification of different types of storage media. Examples for storage media: USB flash drives, secure digital cards, solid state drives, cloud storage, punch cards, hard drive disk, floppy disk, tapes, compact disc, and DVD and Blu-ray disc. Some examples. And computer memory. So basically, computer memory is divided into two parts, known as primary memory and secondary memory. In primary memory, we got ROM and RAM. In secondary, we got magnetic media, optical, and solid state media. First, we got ROM. Read-only memory or ROM is a type of computer storage containing non-volatile permanent data that normally can only be read, not written to. ROM contains the programming that allows a computer to start up or regenerate each time it is turned on. And then magnetic media. The term magnetic media is used to describe any record format where analog or digital information is recorded and retrieved from a coded matrix that can be magnetized. Common types of magnetic media are audio, reel-to-reel, and cassette types. Video and computer tapes on open reels or in cassettes. Optical media. Optical media refers to any data storage device or equipment that uses optical data storage and retrieval techniques to read and write data. It stores data digitally on a media device and uses a laser to read data from it. And solid state media. Solid state storage is a type of computer storage media that stores data electronically and has no moving parts. Solid state storage is made from silicon microchips. Because there are no moving parts, SSDs require less power and produce far less heat than spinning hard disk drives or magnetic tape. Moving on, how data is represented in computer systems. Moving on, how data is represented in computer systems. Data in computer systems is represented as combinations of zeros and ones, known as binary code. It's the fundamental language that computers use to store, process, and transmit information. We got first bits, bytes, data types, binary encoding, hexadecimal, data structures, files, memory, data compression, and endianness. And then, how encryption can be used to compress data. What's data encryption? Data encryption translates data into another form or code so that only people with access to a secret key or password can read it. Encrypted data is commonly referred to as ciphertext, while unencrypted data is called plain text. Currently, encryption is one of the most popular and effective data security methods used by organizations. Two main types of data encryption exist: asymmetric encryption, and also known as public key encryption and symmetric encryption. Data compression. Data compression is a reduction in the number of bits needed to represent data. Compressing data can save storage capacity, speed up file transfer, and decrease costs for storage hardware and network bandwidth. What are the two types of data compression? There are two types of compression: lossy and lossless. Lossy reduces file size by permanently removing some of the original data. Lossless reduces file size by removing unnecessary data. Moving on, how images and sound are represented in computer systems. All computer data, including text, images, and sound, is represented using binary. Work between ASCII and Unicode to understand the relationship between them. Encode images using binary, explore converting between text and sound, and the file formats used to store files. How images are represented in computer system. An image is made of many pixels, each of them with a particular color. Modern computers can show up to 16.7 million of different colors. It is impossible to store each one of these colors personally. They are instead represented as a combination of three primary colors. They are red, green, and blue. RGB color model. How sound is represented in digital systems. Sound needs to be converted into binary for computers to be able to process it. To do this, sound is captured usually by a microphone and then converted into a digital signal. An analog to digital converter will sample a sound wave at regular time intervals. How compression can aid the storage of data, images, and sound. Compression helps by making data, images, and sound by taking up less space. This saves storage to speed up data transfer and reduces the cost. It can also balance between preventing quality of making files smaller depending on the needs. Sound compression is an example of it. Advantages of compression in storing data: reduction storage, fast data transfer, cost effectiveness, preservation of quality, network bandwidth. Moving on, the purpose of logic gates. Logic gates are used to make decisions so that electrical outputs only turn on when the correct logic sequence has been applied. Each logic gate has a name that helps to describe how different inputs will determine the possible outputs. AND gate. An AND gate is an electrical circuit that combines two signals so that the output is on if both signals are present. The output of the AND gate is connected to a base driver which is coupled to a basis of transistors and alternately switches the transistors at opposite corners of the inverter. OR gate. An OR gate is a digital logic gate that gives an output of 1 when any of its inputs are 1, otherwise 0. An OR gate performs like two switches in parallel supplying a light, so that when either of the switches is closed, the light is on. NOT gate. The NOT gate is a digital logic gate that outputs the opposite of a single input signal. An example of a NOT gate would be a game of opposites. NAND gate. NAND is an abbreviation for not AND. A two-input NAND gate is a digital combination logic circuit that performs the logical inverse of an AND gate. NOR gate. The NOR gate is a digital logic gate that implements logical NO. It behaves according to the truth table to the right. A high output results if both the inputs to the gate are low. If unknown both input is high, low input results. No is the result of the negation of the OR operator. XOR gate. The XOR gate acts in the same way as a logical either/or. The output is true if either but not of the inputs are true. The output is false if both inputs are false, or if both inputs are true, it's true. Moving on, and then hardware, software, and transmission media used in computer systems. Routers, hubs, switches, and bridges are some examples of network hardware. Let's look at the fundamental devices of a computer network. For example, modems. A modem enables a computer to connect to the internet via a telephone line. Software media used in computer networks. Software media in computer networks typically refers to the various communication protocols and technologies that enable data transfer and communication within a network. Transmission media used in computer networks. In data communication terminology, a transmission medium is a physical path between the transmitter and the receiver. It is the channel through which data is sent from one place to another. Transmission media is broadly classified into following types. Guided media. In guided media, coaxial, fiber optics, twisted, strip line, and micro strip line. In unguided media, radio waves, microwaves, and infrared. Computer networks. Computer networking refers to interconnected computing devices that can exchange data and share resources with each other. These network devices use a system of rules called communications protocols to transmit information over physical or wireless technologies. These are examples for some networks: PAN, LAN, CAN, MAN, and WAN. Moving on, we got range of World Wide Web technologies. What is World Wide Web? The World Wide Web, often referred to as the WWW, is a global information system that allows users to access and interact with a vast collection of documents and resources linked together via the internet. It's one of the most popular and widely used services on the internet. URL. URL stands for Uniform Resource Locator. A website's URL is its address or location on the web. URLs make it easy to find websites, and they help search engines understand what each page is about. You can use a browser's back button to return to a previous web page. HTTP. HTTP stands for Hypertext Transfer Protocol, and it's a protocol used to transfer data over the internet. Domain name system. A domain name is a unique identifier assigned to each host on the internet. Each host has a domain name associated with its IP address. A domain name identifies a specific host or service on the internet. Hosts are identified by their domain names, which follow the rules defined by the domain name system. It's DNS. DNS translates human readable domain names into the corresponding IP addresses. HTML. HTML stands for Hypertext Markup Language. HTML is what makes websites look nice and readable. It tells different web browsers how to display text, images, videos, and links on a web page. HTML tags tell the web browser where to put things on the page. How www works is an example. Moving on, computer network topologies. What is network topology? Network topology refers to the physical or logical layout of devices and connections in a computer network. It defines how devices are interconnected and how data is transmitted within the network. Different network topologies offer various advantages and trade-offs in terms of performance, scalability, and fault tolerance. Bus topology. Bus topology uses a single cable which connects all the included nodes. The main cable acts as a spine for the entire network. One of the computers in the network acts as a computer server. When it has two endpoints, it is known as a linear bus topology. Then ring topology. In a ring network, every device has exactly two neighboring devices for communication purpose. It's called a ring topology as its formation is like a ring. In this topology, every computer is connected to another computer. Here, the last node is combined with the first one. Star topology. In the star topology, all the computers connect with the help of a hub. This cable is called a central node, and all the other nodes are connected using this central node. It's the most popular on LAN networks as they are inexpensive and easy to install. This is the examples for the topologies. And this is the end of my presentation. Thank you for watching. Have a nice day. Thank you.